So many students struggle to understand the differences between acid and bases. So in this video, we're aiming to break that concept down. We're going to go through common acids, common bases. We'll run through examples of reactions that occur between acid and bases. And really, this is a need to know for any GCSE exam. You definitely need to know acids, bases. So let's go through it in under 10 minutes. What we've done here is we have just got a really nice diagram detailing some common acids. Now, why we're saying common acids as these are common for your GCSE exam. So in your GCSE exam, expect to see the following. So hydrochloric acid, sulfuric acid, nitric acid, ethanoic, and citric acid. What you need to know for each of these acids is you need to know how to recognize them on an exam paper. And by that, I mean, if you see HCl or if you see H2SO4, you need to know that HCl is hydrochloric acid. You need to know that sulfuric acid is H2SO4. The reason why you need to know it is, let's just say that a question involved H2SO4 and the question was saying we've got this H2SO4 here, it reacts with something and it gets the product. Can you identify the product? Well, if you don't know what the reactants are, i.e. if you don't know what H2SO4 stands for, then you're really going to struggle to answer that question. So please take a screenshot, pause this video, write this down, and write down all of these acids, write down their molecular formulas as well, and make sure you are familiar with this. And let's just quickly finish this off before we move on to bases. Nitric acid, HNO3, we write it like this, HNO3. Ethanoic we write out as CH3, COOH, and then citric acid is C6H8O7. Now, the reason why we've included this one is we have seen it pop up a couple of times. Also, generally in classes, depending on if you're trying to achieve maybe a grade 8 or grade 9, sometimes teachers do refer to this as an example. So make sure that you are comfortable with not only identifying the acids from their molecular formulas, but also you can actually draw those molecular formulas by getting these names. So we're going to run through is common bases and alkalis. Now, think of it this way. Acids and bases are the opposite. Acids are between 1 and 6 on the pH scale, and then bases are between 8 and 14 on the pH scale. So they are quite literally opposite. So what we're going to do is we're going to quickly run through these examples, make sure you guys are comfortable with the names and the molecular formulas, and then after that, we're going to really do a deep dive into what defines an acid, i.e. what actually makes an acid, what makes it a base, and then go through the reactions associated. So the first example here, we have sodium hydroxide. Now, this is a very, very common base. It's a very strong alkali, and it is NaOH. We have potassium hydroxide, KOH. We have calcium hydroxide. We have ammonia, which is NH3. Copper oxide, and calcium carbonate, which is CaCO3. Now, these can all come up on your GCSE paper, so make sure you're familiar with them. And again, I'm going to keep saying this and keep saying this. By familiar, what I mean is if a question, say, wrote down NaOH, you need to know that that means sodium hydroxide and so on. Now, the next question we're going to go through is actually the key properties of acid and bases. So we've gone through examples of acids and example of bases, but let's just really start to understand their chemistry. So acids can be defined as basically substances that produce hydrogen ions, which are known as H+, and alkalis produce hydroxide ions. So when you're thinking about acids, I want you to think about H+. When I'm thinking about alkalis, I want you to think about OH-. Now, the reason why they say that when an acid and an alkali react, it's a neutralization reaction is the following. If we get that H+ ion released by the acid and we add it to the OH- ion released by the alkali, we quite literally get the formation of water. Now, water is known as a neutral substance, and that is why these types of reactions are called neutralization reactions. Last thing I promise we are going to run through is actually, well, how do we identify acids and bases? It's all good saying this is what an acid is, this is what a base is, but how do we actually identify them in a lab? Well, what we do is we use something called indicators. Now, we've just listed a couple examples here. If we grab some litmus paper, it would turn red in acid. If we grab litmus, it would turn blue in alkali. If we grab some methyl orange, it goes red in acid, and so on and so on. Now, I'm not going to go through all of these just because we're trying to keep this video very kind of quick, just a very bite-sized revision content. But what I would suggest you guys do is just take a screenshot and just write these down. Make sure you're familiar with all of these types of indicators and how they change in response to pH. Before we conclude this lesson, let's just quickly do a recap of what we have looked at. First thing we looked at is we looked at acids. Now, specifically, we looked at common examples of acids, and that included HCl, we looked at H2SO4, and we did look at others as well. Now, the most important thing you guys need to know is an acid is a substance that releases H plus ions. This is super, super important. The next thing we spoke about is we spoke about alkalis and bases. Now, alkalis, we go through a couple examples. We went through sodium hydroxide, etc. And all you need to know about alkalis or bases is that they release these OH minus ions. The third thing that we went through is the reaction of these two things together. Now, the reaction of acids and bases are known as neutralization reactions. And the reason why they are neutralization reactions is because if you get the H plus from the acid and you add it to the OH minus from the base, what do you get? You get water, and what is water? It is a neutral solution. The last thing we went through is how to identify the different types of acids and bases. How can I identify an acid? How can I identify bases? And you really just need to go through indicators and just make sure you are comfortable with all of that. Now, we are pretty much done. If there's anything you think we could have added to this video, just drop it in the comments. If you think we can improve in any way, again, drop it in the comments. We're always trying to improve our content. And if you want any videos on any specific content, just drop it in the comments again. Keep dropping it in the comments. Let us know exactly what you want a video on, and we will try and reply back to you with a video. But in the meantime, subscribe to this account if you want some quick bite-sized videos, very to the point, just on these essential revision topics. But we'll see you in the next one, and thanks for watching.